Hey guys, all right, so we're going to go through our top three heavy hitters from the Galileo practice from yesterday. I printed off our three questions and I'm going to give you homework similar to these. So really your notes today are just going through these problems and then redoing them, getting a round two to see if we can improve and get better, okay? Now, I'm not going to lie, two of them I'm not shocked by because they are something we haven't quite talked about this year yet. But number one of them, I'm going to show you a strategy to get through it that I think we should feel comfortable doing this particular strategy. Let me show you what I'm talking about. Where's my hover cam? Show all windows. There it is. Okay. So the first one is about probability. And this is one of those, again, we haven't seen too terribly much this year. I know you guys have talked about probability in your previous classes, but I want to remind you of how you can solve these problems. So this one's about Hannah turning on her cell phone. There were 5 images that she has showing up as her screensaver background. Okay. What's the probability expressed as a decimal? That's key, that the cell phone shows an image other than the dog. Okay. So when it comes to probability, there's 2 numbers that you need. The first is how many total outcomes there are possible, right? If I roll a dice, there are 6 outcomes possible, 1 through 6, right? Then on top, the numerator is your favorable outcome. You can also hear this as the desired outcome. Like, what do you want to happen? Like, if I want to roll an even number, well, how many even numbers do you have out of the 6 total, right? We need that number. So the total outcomes here, she's got 3, 4, 5 pictures total. And of those 5, 4 of them are images other than her dog. Now, if you wrote 4/5 in there, it marked it wrong because this is key, expressed as a decimal. So you do need to divide that to get it to its decimal form of 0.8. The second one I noticed that was our heavy hitter was another probability one. It really almost like it's kind of probability plus skill a little bit at the same time. So I'll show you what I mean by that. So there are 50 tickets in the jar. She draws 10 out and she did that 8 times. And she recorded the number of reds that came out of those 10 that she drew. So the best total to get the estimates in the total jar, we need to know how many out of 50 do we expect to be red, right? I can tell you right now, she drew 4 when she had 10 tickets. There's no way she can draw 4 with 50 tickets. That would not be the best estimate at all. Now there's something you can think about too, like she randomly drew 10, right? Now what I want to do really is figure out of the 10, like on average, what was the number of red tickets? I could easily plug a 3 in here and try and solve that proportion. I could plug in a 4, a 6, a 7. There's all sorts of numbers, but that would really just give me that range of options. Let me find the average. Okay. So I'm going to say, actually, I'm going to show you a cool mental math trick instead of adding all these individually in the calculator. I see 6 and 4, which make 10. I see 3 and 7 make 10. 3 and 3 make 6, plus 4 makes 10, plus 2. So I have 32 total, and then divide by the 8 times she did that. So 4 was the average number of red that she drew. 4 is a little under half of 10, so the number I'm looking for is a little under half of 50. So I know 32 is out. And if I prove that with my proportion here, you say I'm like scaling it up, right? I have 20 is the best estimate. These were definitely the 2 they wanted you to tug a war with, okay? Last but not least is a percent change question. So we have studied this year, but this question, I know it throws kids, or it has in the past when I've done this, just because of the wordiness, right? It's the words, not the math. So Julia uses a scale. She weighs 3 stacks of identical coins. It tells me there's a max percent error of 3%. It tells me what the first and second stack weighs. Now, if they're identical, I have to keep that in mind. I already see a little percent error showing, right? We're gonna round to the nearest 10th. What's the greatest possible amount the scale could say for the stack of the third coins? So remember, it says it has a maximum percent error of 3%, which means I could have 3% being added on to this one. And I could have 3% being added on to this one. Now, I don't have to do both of those questions because it asks for the greatest amount. Well, the greatest amount would be an increase 3% of the 10.3, okay? So I'm gonna figure out what 3% of 10.3 is. Same as we've always done with percent proportions. Okay. So we have 3 over 100 times 10.3. All right, so x equals 0.309. Remember, that could be an increase. So if I add that on, 10.3 plus 0.309. So 10.6 rounded to the nearest 10th is my highest possible weight for that particular stack of coins, okay? All right, well, I'm gonna come up with some questions for you to do like this for homework, and hopefully you guys feel better and improve, all right? I will see you for our meeting.